evening, my YouTube viewers. In this video, I'm going to be talking about gradient boosted trees for time series. And although gradient boosted trees work differently than LSTMs do, they still use a little bit of the same process to do time series forecasting that LSTMs do. So for that reason, what we're going to do is we're going to create a program that uses gradient boosted trees to make a forecast of values for 1 year. Okay, so the first thing that we're going to do is we're going to import some libraries that we need to import in order to execute the program. So the first library that we're going to import is going to be NumPy as NP, which is the numeric library that also creates NumPy arrays. And then we're going to import Pandas as PD, which is a data processing library that creates data frames as well. We're going to import matplotlib.pyplot as PLT, which is the visualization library. So from sklearn.model-selection, we're going to import train test split. So sklearn is Python's machine learning library, and model selection is a module within sklearn. And the train test split function, what it does is it splits the data set into training and testing or training and validation sets. And then from sklearn.metrics, we're going to import mean squared error. So that means what we're going to do is we're going to measure the error of the predictions versus the true data. And we're going to measure that using a mean squared error. So the lower the mean squared error, the better the accuracy of the prediction is. And from XGBoost, we're going to import XGB Regressor. And XGBoost is a gradient boosted regressor, and that's what our model is going to be to actually form a time series forecast. So we're going to generate some synthetic data for about a year. And then so the first thing that we're going to do is we're going to set our seed. And what happens when you set the seed is every time you execute the program, the values will be the same. So that means that the program will run the same every time you execute it. And so you set the seed by typing in np.random.seed, and then you can put any number you want within the brackets. And now we set up our time steps, which is np.arange 365. So you're going to have 365 steps for 365 days of the year. And then your series is going to be 10 plus 0.05 times time steps plus 2 times np.sign brackets 0.1 times time steps brackets plus np.random.normal. And normal is a normal distribution, brackets 0, 0.5, then time steps. So 0 is your mean, 0.5 is your standard deviation, and the length of the time steps is the sample size, and the sample size is 365. So now we're going to prepare the data for supervised learning, which is going to be very similar to the way we prepared it in the last video when we covered LSTMs. So we're going to create a function called create features, and it's going to take the data and lag as the arguments. So x, y is to empty list. For I in range, brackets lag, len data. So the length of the data is 365. and the lag is going to be 10. So x dot append data square brackets I minus lag colon I square brackets. That's the lagged value as features. And y dot append brackets data square brackets I brackets. And that's the current value as target. And you're going to return after it has created, incremented through 365, it's going to return the array of x, which will have 365 variables in it, elements in it, and an array of y, which is also going to have 365 elements in it. And so lag equals 10. That's the number of lag steps to use as features. X, y equals create features, brackets, series, lag. So lag is 10 and series is 365 with your series that we've created. So now what we're going to do is we're going to use train test split to split the data into training and testing set. And the training set is 80% and the test set is 20%. And now what we're going to do is we're going to fit the gradient boosted trees. That's the XGBoost model. Model equals XGB Regressor, brackets N estimators equals 100, comma, learning rate equals 0.1, comma, max depth equals 3, comma, random state equals 42, and then model.fit X train, Y train. So now we're going to make predictions on the test data. So ypred equals model.predict X test. And now we're going to calculate the performance metrics. MSE equals mean squared error, brackets, y test, comma, ypred. And then we're going to print the mean squared error. So let me just see what the mean squared error is. Mean squared error is 4.5753. And the lower the mean squared error is, the higher the accuracy. You want the mean squared error to be as low as possible. And so now what we're going to do is we're going to plot the results onto a graph. plt.figure, brackets, fig size equals 6,4, plt.plot, brackets, range, brackets, len series, that's 365, I think, comma, series, comma, label equals true values, comma, color equals blue, comma, alpha equals 0.6. plt.plot, range, well, brackets, range, brackets, len x train. So that's going to be 80% of 365 plus lag, and your lag is your 10 because that's been predefined, comma, len series, so that's 365, comma, ypred, comma, label equals predicted values, comma, color equals orange, comma, line style equals dash. And now we're going to put a vertical line in the graph, plt.axv line, brackets, x equals len x train, plus lag minus 1, comma, color equals gray, line style equals dash, comma, label equals train test split. And then now we're going to add labels, title, and legend to the graph. So the title is Gradient Boosted Trees for Time Series Forecasting. The X label is time steps. The Y label is value. You get a legend, you get a grid, and we're going to show it. So this is the graph that we've produced with Matplotlib. It's gradient boosted trees for time series forecasting. The blue is your true values that we have created. The orange is the predicted values. And so you can see that the predicted values follow the blue values to a certain degree, and then it just goes straight at 25. And the looks like it's a gray is your train test split. So that's the split between your training data and your testing data. So the training data is 80% and the testing data is 20%. So that concludes this video. The next video is going to be another subject on time series forecasting, and so I hope that you decide to watch it.